Hello everyone, welcome to Shorov's classes. Hope you all are doing well. So welcome to our next session, tomato problem solving session, objective part. So as I have said that those who are following the series of videos, they are already aware of this, and those who are new to this video, I want to say that this video is meant for students who are aimed for I.S.I and CMI entrance examinations, and tomato stands for the abbreviation of this book, Test of Mathematics at 10+2 level, published by Indian Statistical Institute themselves. So these problems that are present in the book are really very ingenious, and they want you, and I.S.I professors expect you to come prepared with these problems, because these are the problems you will be facing at the examination. So in the examination, as I have told, that there will be two parts, the subjective and the objective. So now we are aimed to solving the objective part. So let's get to the first question. So the first question says, that the number of elements in the set so the set I define it as follows. So S equals 1 plus omega whole power n, where m comma n are natural numbers, R. Option A, 4, 5, 7, infinity. Okay, so this is the question. It says that the number of elements in the set S equals 1 plus omega squared dot omega power n, where n belongs to natural numbers, are 4, 5, 7 or infinity. So now we are mainly focused on this problem. So now we want to know that what basically omega is. So omega is what we know as the complex cube roots of unity. So the solutions of the equation this are 1, omega and omega square. So these are the solutions of this equation, and as you can see from the theory of equations, we can say that what is the sum of the roots of these roots, which is equals to the coefficient of x square by the coefficient of a, but the coefficient of x square here is 0. Therefore what we get is 1 plus omega square equals to 0. So that was the main concept, that the driving concept that will solve this problem. So now what we have to do is, so now we see that some of the terms here are getting to 0. So we see 1 plus omega square is 0. So you can very well see that infinity is rejected. So this process that I use is known as the option elimination process. So I eliminated an option based on the logic or the knowledge that I have. So now let's consider the numbers, since m and n are natural numbers, so they can be both odd, even, or particularly in 3k plus 1, 3k plus 2 or 3k form. So let m be of form 3k. Okay, so what do we get is that 1 plus omega square can be paired up, plus again I get a 1 plus omega square if I take omega common, and then up to every term I can pair up 1 plus omega square. Now what did I say, that 1 plus omega square is 0, and therefore when it is 3k it comes to 0. Now for the combinations of 3k plus 1 and 3k plus 2, we can see that the only values that it can approach to are 1 minus omega square, omega minus 1, omega square minus 1, omega square minus omega 0. So how many distinct values are here? 1, 2, 3, 4, 5, 6 and 7. So since 7 distinct values are there, so 7 is the answer. So remember that for these types of problems, what we have to do is that we need to just check the parity or the remainder checking, or more specifically I call this thing as remainder check. So remainder check is a very important tool in mathematics. So I just want to get into the next problem now. So the next problem says that if omega, so again it's given that x equals omega power 2009 to the power of 2009 and dot up to infinity. Then x by 1 by x. So x by 1 plus x is question mark. So what is x plus 1 by x in the question? Now you observe that any power of 2019 is odd. Okay. Now we see that 2009 is congruent to minus 1 mod 3, and we see that 2009, and if I raise to the power of 2n plus 1 is also congruent to minus 1 mod 3. Therefore x congruent to, so I don't write congruence here, I write, so x equal to omega power dot whatever the expression might be. So I am just aiming at this expression to be here. So x is omega power minus 1 mod 3, which is nothing but omega square, isn't it? Therefore x plus 1 by x answer. So this is the problem. So we see that when we have an infinite, so we call these things as tower exponents, and we saw that how can we deal with tower exponents concerning modulo. So modulo basically helps us to decrease the tower exponents and get it in a much more simplified form. So that's all from this session. I will come back in the next session with some new problems. So till then, stay tuned.